A solution has a solvent and a solute as its components. The component of a solution that dissolve the other component in it, usually the component present in larger amount, is called solvent. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called solute. So solute plus solvent will give you solution. Now, which are the different types of solution? A solution of sugar in water is solid in liquid solution. In this solution, sugar is solute and water is solvent. So this is solid in liquid type of solution. Second, a solution of iodine in alcohol known as tincture of iodine has iodine solid as the solute and alcohol as liquid as the solvent. So this is also solid in liquid type of solution. Third one, aerated drinks like soda water etc. are gas in liquid solutions. These contain carbon dioxide gas as solute and water liquid as solvent. So it is a type of gas in liquid. Fourth one, air is a mixture of gas in gas. Air is a homogeneous mixture of number of gases. Its two main constituents are oxygen 21% and nitrogen 78%. The other gases are present in very small quantities. So this is a type of gas in gas. Air is a mixture of different gases. It is a type of gas in gas. Now what are the properties of solution? A solution is a homogeneous mixture. The particles of solution are smaller than 1 nanometer in diameter, so they cannot be seen by naked eyes. That means particles in a solution are very small. They cannot be seen with our naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of the light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. That is, solution is stable in nature. Now what do you mean by concentration of a solution? We have observed in activity 2.2 that group A and group B obtain different shades of solution. So we understand that in a solution the relative proportion of the solute and the solvent can be varied. Depending upon the amount of solute present in a solution, it can be dilute, concentrated or saturated solution. Dilute and concentrated are comparative terms. In activity 2.2, the solution obtained by group A is dilute as compared to that obtained by group B. Activity 2.3, take approximately 50 ml of water, each in two separate beakers. Add salt in one beaker and sugar or barium chloride in the second beaker with continuous stirring. When no more solute can be dissolved, heat the contents of the beaker to rise the temperature by about 5 degrees Celsius. Start adding the solute again. If the amount of solute and sugar or barium chloride that can be dissolved in water at the given temperature the same, at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature is called saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called unsaturated solution. What would happen if you were to take saturated solution at a certain temperature and cool it slowly? We can infer from the above activity that different substances in a given solvent can have different solubilities at the same temperature. The concentration of a solution is the amount of mass or volume of the solute present in a given amount mass or volume of a solution. There are various ways of expressing concentration of a solution, but here we will learn only three methods. Number one, mass by mass percentage of solution is equal to mass of solute upon mass of solution multiplied by 100. Second, mass by volume percentage of solution is equal to mass of solute upon volume of solution multiplied by 100. And third one, volume by volume percentage of solution is equal to volume of solute upon volume of solution multiplied by 100. Let us solve one example. A solution contains 40 grams of common salt in 320 grams of water. Calculate the concentration in terms of mass by mass percentage of solution. So, solution answer. Mass of solute, that is salt, is given 40 grams. Mass of solvent water 320 grams. So when you add it, you will get the mass of solution. Therefore, mass of solution is equal to mass of solute plus mass of solvent, that is 40 grams plus 320 grams, you will get 360 grams. Mass percentage of solution is equal to mass of solute upon mass of solution multiplied by 100. Therefore, 40 upon 360 multiplied by 100, you will get 11.1%. Now, what do you mean by suspension? A suspension non-homogeneous system like those obtained by group C in activity 2.2, in which solids are dispersed in liquid, are called suspension. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of the suspension are visible to the naked eyes. Now, what are the different properties of suspension? Suspension is a heterogeneous mixture. Second, the particles of suspension can be seen with the naked eyes. So we can see the particles of suspension with our naked eyes. They are very big to see. The particles of suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when suspension is left undisturbed. That is, a suspension is unstable in nature. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. For example, chalk in water is an example of suspension. Now, what do you mean by a colloidal solution? The mixture obtained by group D in activity 2.2 is called colloidal solution. The particles of colloid are uniformly spread throughout the solution. Due to the relatively smaller size of the particle as compared to that of suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture, for example, milk. Because of the small size of colloidal particles, we cannot see them with our naked eyes. But these particles can easily scatter beam of light as observed in activity 2.2. This scattering of beam of light is called Tyndall effect, after the name of the scientist who discovered this. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to scattering of light by the particles of dust and smoke in the air. What do you mean by Tyndall effect? Tyndall effect can be observed when the sunlight passes through the canopy of dense forest. In the forest, mist contains tiny droplets of water which act as particles of colloid dispersed in air. Properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of colloid is too small to be seen with the naked eyes. Colloids are big enough to scatter a beam of light passing through it. And makes its path visible. They do not settle down when left undisturbed. That means colloid is quite stable in nature. They cannot be separated from the mixture by the process of filtration, but a special technique for separation known as centrifugation can be used to separate the colloidal particles. The components of a colloidal solution are the disperse phase and the dispersion medium. The solute-like components or the dispersed particles in a colloid form the disperse phase, and the components in which the disperse phase is suspended is known as the dispersing medium. Colloids are classified according to the state solid, liquid and gas of the dispersing medium and the disperse phase. A few examples are given in table 2.2. You can see that they are very common day-to-day life, in our everyday life.